Which question? 8A. Okay. Let's see. Mahmood? Attendance? Yeah. Gafar? There you are, right in front of me. Amjad? There you are. Zara? Yeah. Mawafa? I really want to just call you Mo. That's cool. All right. Just seems like that should be your.
Yeah, it is. Always.
All right. Then Mo it is. Daniel? Savi? Where? Oh, there you are. Sabrina? Alfreda? Aria? C1? What is it? No, I'll have to write it down properly. Chidia, what? Slowly, please. Chi-A-D. Chiadi. Okay. Yupang? Amna? Mariam. Okay. So now I've got it mastered now. There's Chiadi and Chidira. Yeah. I have to spell it phonetically though. Right. Okay, so page 40. 8A, yeah? Yeah. Do you have a good time trying to solve it? Yes? Yeah. Do you feel like you made progress?
No.
Good. Right. The ninth term is minus 6561. And the sum of the first two terms is 2. Yeah. Well, I hope you got this part okay. I just say A or 8 equals minus 6561. Yeah. And this is A 1 minus R squared over 1 minus R equals 2. Yeah. Is this okay so far? Yeah. Right. Now, what to do next? Yeah.
Say something? Can't you do it like U2 is equal to 2 minus A?
U2?
Yeah.
U2?
U2 is equal to 2 minus A. Can you do it like that? And that would be, yeah, and that's how you use, then you can use the UN, the other one, the equation. Am I right? Am I wrong?
This is interesting. I see what you're saying. So you're saying that U2 is 2 minus A because U2 plus A should be S2, which is 2.
Yeah.
Yeah. And then what would you do with this?
Then you would use the formula, the UNA times R n minus 1, and so it could be 2
no. This is
minus
geometric.
Yeah, then...
Oh, sorry, yeah.
Yeah, then it could be 2 minus A.
So this is A, you say this is AR?
Yeah.
Yeah, okay.
So it would be 2 minus A is equal to A times R to the power.
No, I get it. Cool. I like it and it works.
Yeah.
But it only works for this one because it's S2. Yeah. If I said S3, then it doesn't work.
Yeah.
So I like your method works, it's a smart method, and I'm not going to do it that way because I want to show you a way that works for all types. Yeah? But you got the right answer using this method.
Yeah.
That's good. The S2 is what helped you there, yeah. But what would you do if you couldn't do that? So if it was something like S3 or S4. So I can simplify this by doing a long division. And you can simplify it down to A 1 plus R equals 2. But of course this makes sense because S2 is just A plus AR. So obviously that makes sense. And here I can say A is 2 over 1 plus R. Likewise here I can say A is minus 6561 over R8. Yeah. So I can equate them. So I get minus 6561 over 2 equals, sorry, over or 8, I'm getting ahead of myself here, over or 8 equals 2 over 1 plus or, which I can change that into minus 6561 over 2 equals or 8 over 1 plus or. Now that's a difficult equation to solve. Yes. It's difficult to solve. How to solve it? Let's have a look. So, I want to solve or 8 over 1 plus or equals minus 6561 over 2. So what I'll do is I'll just change this into or 8 over 1 plus or equals 6561 over minus 2. Same thing, right? Now, what is minus, if I was to change minus 2 into 1 plus a number, what number would that be? Minus 3. And I hope you can see that 6561 is obviously minus 3 to the power of 8.
Yeah.
Yeah. So if you were to compare this equation with this, I think you can reach only one conclusion on what the or should be. Or has to be minus 3. So, with the or equal to minus 3, you can sub that back into, say, this equation here to get the a. So, if the or is equal to minus 3, then the a will equal minus 1. And that's the answer. Yeah?
Why didn't you cross multiply, or is that even possible?
It's possible, but it doesn't produce a solvable equation. Because you'll end up getting an equation like or 8.
Couldn't you just make that like or like anything to the power of 2 and make it productive?
Can't, because it's or 8 and or. If it was or 8 and or 4, you could. But because it's or 8 and or, you can't.
So R is minus 3 and A is minus 1.
Yeah. Wrote that down? Yeah. Yeah.
For
Yep. Yeah.
question 9a, I also found another method.
Yeah.
Instead of doing
Now
the
this
plus-
might be the method I saw from Young Peng.
Yeah,
Is it possibly the middle squared?
Yeah, the middle square
Is the
equal
first-
to is equal to the minus 8x minus 4 brackets minus 2x plus,
Yeah.
plus 3. Then can't you just
And you get the same answer.
expand and then do long division?
Yeah. Yeah, you get the same answer.
Yeah.
Yeah. There's a small thing I don't like about that, which I'll show you now, but it should work.
It's using the quadratic formula you get to answers.
No, I don't know,
Plus or
dude.
minus.
Okay. If you look at 9a on that page, you can say that minus 4x minus 4 over minus 2x plus 3 equals minus 8x minus 4 over minus 4x minus 4. Yeah? That's one way to solve it. You know, the second divided by the first is equal to the third divided by second. But there is a second method which a couple of students now have mentioned, which, so if I was to write this method out, this one up here, it would be like saying second over first should equal third over second. But there's another method that says the second squared is equal to the first by the third. Now, you think about it, both methods make sense. You know, if I have a sequence A or squared, yeah, the second divided by the first is or, and that does equal the third divided by the second. But this method also works because the second squared is A or squared, and that does equal A by A or squared. So you can also arrive at this equation. What's the first one here? Now, there is an absolutely tiny difference between these two equations. It's absolutely tiny. But there is a small difference between these two methods and these two equations. Now you might be looking at it saying, no there's not, because if I took this equation and just brought this up here and brought this up here, it'd be the same. But there is a difference. And I want to know, what is that difference? What the heck is green? There we go.
Sir, can you, the speaker white noise,
You don't find it common, the white noise?
Yeah,
No.
it's fine.
There we go. Okay. What's the small difference between these two? There is a difference. Can anyone see it? They're not actually the same problem. No, they look the same, don't they? Yeah. It's like, what the heck is this guy talking about? I'll tell you what the difference is, okay? In this first equation, you're... yeah?
I think I know. Is
Go.
it the square?
Yeah, what about it?
Wouldn't that use the chance of giving you two?
Well, that's him first, and then we'll hear you. Go on.
Wouldn't that mean that you would have like two possible answers?
Not necessarily, possibly, but you could say the same thing about the first equation. They both could have two answers. And you?
Should be positive.
Give me more.
Oh, it could
Wait, hang on. You had your chance. Now he's telling me. Go on.
Because it's a square, so...
I know you want attention. Put your hand down. Hand down. Go on.
Should be positive only.
Yeah, go. Give me more. You're close. Give me more.
When you do square...
Put your hand down.
Negative 4, it would be just 16. If you do it in the other way, maybe negative...
I thought you had it, but I don't think you do. Right.
X can only, X in the first equation cannot be, I think it's -1, and you don't have that within the second one.
You are halfway there. Yeah, halfway there. That's true. That's true. So, in the first equation, you're allowed to have x could be any real number except for -1, because you can't have a 0 here, and except for 3/2. So, here it's any real number except for those two. Okay? Whereas in this one, the x could be any number from, I think it's something like -infinity to a half. I can't quite remember. And then something like 5/7 to infinity. I don't quite remember. But my point is that for this one here, you have a range. It's -infinity to some number, and then some other number up to infinity. So in other words, there's a gap missing. Now why is there something missing that we can't consider in the second one? Well, it is because of the square. You see, because this is a square, it means this side is positive, right? Which means I'm only allowed to consider values of x that make this one positive. Yeah. See, this is what I thought you were trying to get to. Whereas with this one, I'm allowed to consider any value of x except for what makes these two guys 0. So if you were to look at it, if the x was something that was in between a and b, then you couldn't use it here, but you could use it here. If the x was, suppose that this equation had an answer that x is -1, would that be okay? In this one, could x be -1? It could be. Why would it be a problem with -1? Yeah, you see, that's the thing. It doesn't cause any problems here. But in this one, if x is -1, would that be okay? No, because it would make the first, it'd make a denominator 0. And this is what I'm saying. Although they look the same, there is a small difference between what's possible for x. So I actually prefer the first one, because it only forbids two values of x. Whereas in the second one, not only does it skip a piece between A and B, you're also allowed to use values of x that you really shouldn't be using in the first one. You know. These are small differences, but you know they're worth considering and thinking about. So who's asking me this? Yeah.
So
You should get the same answer though.
yeah. So if you get it, you can obviously expand and then do the quadratic
Yeah.
and then make it equal to 0 or whatever. But why can't we just divide by minus 4x minus 4 on both sides, and then
On which equation am I looking at? 1 or 2?
1
Yeah.
after you cross multiply?
Yeah.
And then can't you just divide, because you have a square? Can't you just divide by minus 4x minus 4 and then do long
After you
division?
cross multiply?
Yeah.
After you cross multiply, you'll get this. Because that guy goes up and that guy goes up.
Yeah.
So what would you do next?
Divide by minus 4x minus 4 after you expand there to the right. That way you can do long division to the right, right?
Oh.
Yeah.
Okay. That
Would be easier than using the
might
quadratic formula, right?
might work, but I would have expanded left and right because I deliberately made it so that the quadratic cancels out and it's only linear.
Yeah. But I'm just thinking of a possibility if it's minus and plus.
I feel like long division won't work here
More.
because I don't think your remainder will be 0. I'm pretty sure that your remainder won't be 0. Yeah. The reason I'm sure of this is because if I could divide minus 4x minus 4 into the quadratic you get here, is that a dog? Then I think one of these guys should have been minus 4x minus 4,
Yeah.
which they're not. So I'd be reluctant to try that. Okay. I think that's a good discussion on number 9 there. What's next? Which one? Yeah, number 10, I'm going to hold off until you do lesson on page 46 because it'd be a little bit better if number 10 was optional. So after we do, so in other words, we can do it next week in the tutorial. Okay. So what's next then?
Okay. Page 32.
32. Yeah.
Question 5A.
You want to see it?
Yeah.
Your life won't be complete until you see it.
Yes.
Yes. Okay. All right. It's a tough one.
Yep.
Did you get any of the values?
I tried, but it's wrong. I have to tear the whole paper because that was frustrating.
Yes. Yes. All right. Px plus q power n equals minus 64 minus 96x minus 48x squared dot dot dot. Let's expand on the left here. So that is NC0, yeah? PXQ plus NC1 PXQ plus NC2 PXQ equals minus 64 minus 96x minus 48x squared. Okay, let's put in the power. So what power do I have on the first guy? On the px? 0, because it starts with no x's. And then this guy?
2.
Oh, no. N.
Oh, okay.
Yeah. And this one? 1, and this guy? Yeah, and here? 2 and minus 2. So, what's MC0? What is the first number on any row? 1. And PX0? 1. So that's QN. Now, what is the next number on any row? If you think about it, we were talking about the Pascal's triangle. What did we notice about the next? It's n. Yeah. So the next number is always the row number. So on the 5th row, the next number is 5. So on the nth row, the next number in is n. So that's n, p, q, n minus 1x. Now it gets interesting. NC2. Let me go to the side and calculate NC2 for you. So NC2 is equal to n factorial over 2 factorial n minus 2 factorial. Yeah? Now what's n factorial? N multiplied by what's next? Next? And when do I stop? When I get to... No, I get to 1. It decreases down to 1, doesn't it? 2 factorial? N minus 2 factorial? Until 1. Now what cancels here? A lot. Cancel, 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 cancel. N minus 3, n minus 2. So I'm left with n minus 1 over 2, which is n squared minus n over 2. So that's actually a formula for the next number in on the row of Pascal's triangle. So that's the NC2. Yeah, that's the coefficient. Okay, I need to scroll back, so if you need to write this down, do. So like for example, if I said what's 10C2, I can use this formula. It would be 100 minus 10 over 2, which is 45. So if you type in 10C2, you should get 45. So like it really does work. Yep. Back we go. Yep. So that's, where am I? This guy.
Yep.
N squared minus n over 2 p squared q n minus 2 x squared dot 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 equals minus 64 minus 96x minus 48x squared dot dot dot. Now let's compare. So we can make 3 equations. Equation 1. Qn should equal what? Minus 64. Equation 2. npqn minus 1 should equal minus 96. And equation 3 is n squared minus n over 2 p squared qn minus 2, that should equal minus 48. Alright, now we have to solve for p, q and n. It's a bit tricky because the equations are quite complicated. So let's have a look now. Can I scroll down a little bit? Right, could I scroll down like one line, like to here?
Yeah.
Okay. So I kind of want to clean these up a little bit before I start doing anything with them. So the first guy, I'll leave him alone. Qn equals minus 64. The second one, I'll change this into npqn over q equals minus 96. And on the third one, I'll say that's n squared minus n over 2 p squared qn over q squared equals minus 48. Now there's something that you notice that's kind of in common with equation 2 and equation 3. In both of them you have a p over q. So let's clean them up again a little bit more. So equation 1, I'll keep it the same. Qn equals minus 64. Equation 2, yeah, I'll change it into n p over q, qn equals minus 96. And equation 3, I'll change that into n squared minus n over 2, p over q squared, qn equals minus 48. Okay, so let's start simplifying here. So what you notice is that you have a qn in equation 2 and equation 3. Yeah?
So just use
Use equation 1. So what we'll do now is we'll take this guy and we'll put it in here for the qn and we'll put it in here for the Qn. So now I get equation 2 is n p over q minus 64 equals minus 96. And then in number 3, I have n squared minus n over 2. What is this now? This is still p over q squared, but this is now minus 64. That equals minus 48. Okay, let's clean these two guys up here. Equation 2. 96 divided by 64, is that 3 over 2? Okay, and 48 over 64? So n squared minus n over 2, p over q squared equals, what did we say? 3 over 4, yeah, okay. Right, now, what do we notice we could substitute next? Well, let me just move somebody out of the way. Let me just bring that n down to here.
You have P over Q.
I have p over q.
In terms of n.
Yeah, so put this guy in here. Now equation 3 becomes n squared minus n over 2, 3 over 2n squared equals 3 over 4. Now, this is kind of success because I reduced my problem down into just one equation of one unknown. In fact, what type will this be? It's quadratic, isn't it? Yeah. So I'll get, I'll bring this 2 by 2 is, oh that's, sorry, yeah.
Square.
Yeah, 2 squared is 4. So this 2 is actually a 4, so I can cancel it with that one. I can bring this 2 up here to make that a 6. Oh, and 3 squared is 9, so I can bring that down there. 6 over 9, 2 over 3. So I end up getting n squared minus n over n squared is 2 over 3. So I get 3n squared minus 3n equals 2n. 2n squared, thank you. So then I get n squared minus 3n equals 0. So I get n by n minus 3 equals 0. So obviously n is not 0. So I get n is 3. Now that I have that, I can sub it back in. Where can I sub this in? Oh, I think not the p over q one, the other one. The this guy. So I know that q cubed should equal minus 64. So therefore q has to equal minus 4. And now I can use the fact that, what did I say, p over q equals 3 over 2n. And 2n is, yeah. Oh, and I know the q is minus 4. So the p will be a half of minus 4, which is minus 2. Yes. N is 3, q is minus 4, p is minus 2.
Can I see that for the time?
Oh yeah, for sure. 28. So you probably have to jump back to like 20.
Okay. Could something like this come in there?
No. This was only to annoy Mo. It's the only reason I made this question. I mean, if I don't keep him busy with this, he'll just be playing Fortnite and doing nothing else. I have to distract him.
I don't do Fortnite, sir. I do CSGO.
Alright, okay. Excuse me then. Okay. Tricky one, yeah? Very tricky.
Didn't we do something similar to this in class, but in a completely different way? Or am I-
No. The only one we did in class had 2 unknowns. Right, what's next? Yeah.
Number, page 34.
Yeah.
5.
5.
Yeah.
Which sequence though?
V and maybe V and M, because I'm still having a hard time like differentiating between
V and M.
yeah, between divergent and convergent.
Okay, V and M then, yeah?
So like
Yeah.
any two that have divergent and convergent.
What
Like
time?
E and F.
E and F.
E and F.
Okay, E and F. E and F. Fair enough. Right. Can I scroll down?
Just one second.
Okay.
Done.
Yep. Okay. Scroll down. Not yet.
34. 5 E and F.
Scroll down. Right. So now we're looking at E, you said. Vn plus 1 equals 3 over 2 Vn. Okay, and where do I tell you to start in this sequence? 1. So, V1 equals 1. V2 will equal 3 over 2 times 1, which is 3 over 2. V3 is 3 over 2 times 3 over 2, which is 9 over 4. V4 is 3 over 2 times 9 over 4, which is 27 over 8. Now, if you look at what's happening here, this is equal to 1, this is 1.5, what's this now? 2.25? 3.375, is that right?
Yeah.
Yeah. V5 is 3 over 2 times 27 over 8, which is 680, 1 over 16, isn't it? So anyways, what's clearly happening is this is just getting bigger and bigger. So we say it's divergent.
Okay, the thing is that how many points would be enough? Like I don't see like
I said in the question 6.
How do you know there is a limit to it? There is no limit.
no, but like that was for question 4, not for question 5.
OMG.
Yeah.
If I just asked you for 6 terms and then my follow-up question is, do you think it's convergent, divergent or periodic? Do you think I'd be so diabolical that I would make you get more terms? Really?
Did you see the last question we solved?
I know, but come on now. It'd be somewhat reasonable. So obviously I felt 6 was enough, since that's what I asked you to do previous to this. So 6 would be plenty. In fact, I didn't even need to do 6 here. I got a pretty good idea after 4 that it was divergent.
And the example they tell us how many terms.
Yeah, yeah.
What's the time, please?
That one, 33. Right. What's the other one? F.
Same page, number 7.
Yeah, 34. Number 7E and now 7F. So Vn equals minus 7 plus 4 over Vn minus 1. And I start at 8. So first I have 8. Then I'll have minus 7 plus 4 over 8, which is minus 7 plus a half, which is minus 13 over 2. V3 will be minus 7 plus 4 over minus 13 over 2, which is minus 7 minus 8 over 13. Which whatever it is, I don't know. This one here I feel is, well, you know what, I think I'm needing my calculator now. It's getting a little bit tricky. I can't tell after 3. I'll need to go to 6 and I'll need my calculator. I don't know, it could be convergent? Could be?
Could it?
The reason that makes me feel like it's convergent is because if it was divergent, then it would mean the sequence is going to infinity. And as the terms come okay, I'll explain my logic here. Guys, can you look up? V n equals minus 7 plus 4 over Vn minus 1. I think this sequence is convergent, and my logic is this, okay? If it was divergent, then V should be big at some point eventually, right? So I don't think this sequence is compatible with having big values. Why? Well, imagine that my value was big. What would be the next value? It would be minus 7, yeah, plus 4 over a big number. Now what's 4 over a big number? It's very small, so I'll get minus 7. So this is why I don't think it's divergent, because it's difficult for me to imagine how this sequence could become very large, because every time it becomes very large, it gets snapped back to minus 7 due to the nature of the formula.
So it's convergent.
Well, no, not definitely. Not definitely. Like, it could be divergent. It's just difficult for me to imagine how it would achieve getting to infinity.
Okay.
Like, for example, if Vn minus 1 suddenly became 0, if this suddenly became 0, yeah, it would break to a divergent infinity. Anyways, let's see what we get on the calculator. That will help us out. What term do I tell you to start at here? No, 8, isn't it?
8.
Yeah, and what's my formula? It's minus 7 plus 4 over answer. So, minus 13 over 2, which is probably what I said, I hope. Minus 99 over 13. Okay, so if we just keep going, yeah, it's convergent to something which is roughly 7.5, minus 7.5. So it's looking convergent for sure. Yeah.
So on the exam we can use the calculator and just write the number.
No, I'll get to that in a moment. Yeah?
Yeah. Is it? You said that when it's divergent, it's always going to infinity. Is it possible to have it
Yeah.
divergent to negative?
Yeah, and it's also possible to have it divergent, but neither to positive or negative infinity. And let me give you an example. Yeah, let me give you an example. So, consider this sequence. We'll make it simple enough. We'll say un equals minus 1 power nn. Okay? So, what is u1 here? What's that? Minus 1. Okay? u2? Positive?
Yeah, it's possible.
Positive? Positive what?
But how can you power negative?
What's wrong?
Oh.
It's just minus 1 power n times n.
Yeah.
Yeah. What's u3? Minus 3. What's u4? 4. See what's happening here? u5? Minus 5. Is this convergent? Is it convergent? Convergent. Is it? No.
Is it considered periodic?
No. Is it periodic? No. Is it convergent? No. If it's not convergent, it is automatically divergent. Automatically. So if something is not convergent, it is automatically divergent. It's switching back and forth. But it's wrong to say it's going to infinity.
Isn't switching back and forth periodic?
No. This doesn't repeat itself. There is no number which is the same as an earlier number.
I get that, but isn't like diverging like at least in the graph form, isn't it like this?
Well, no, this is the point I'm making. This is the point I'm making. Not always. Okay? So, what is the rule? The rule is this. First, is it convergent? If the answer is no, it's automatically divergent. Usually divergent means going to infinity or minus infinity. But here's a situation where it is neither going to plus infinity or is it going to minus infinity. In fact, in some way it's trying to go to both at the same time. Now the graph would look like this. Kind of like a sine. It's obviously not convergent, it's divergent, but it's neither positive or negative infinity. So it's divergent to a undefined place. At least the sequences we had earlier were divergent to a particular place, plus infinity or minus infinity. Okay.
Can you give an example of a conversion?
A convergent one? And what do you want special about it? I can custom make it for you. What do you want?
I want to know how to differentiate this from a conversion.
Oh yeah, so like, yeah, so how can I change this to make it convergent? I could make a little change to it. Firstly, I'll get rid of this minus business. I'll say un equals 1 over n. Okay, so what's the first term? 1. Second term? Half. Next one? Third. If you were to look at this graph, it's going like this. This is convergent to 0. Yeah?
Just remove the negative 1 to 1, wouldn't it also convergent this way?
In which, this one here?
Yeah,
Remove this guy?
no, just remove the negative sign, so 1 and isn't it just convergent?
If it's 1n times n, what? Still divergent. Because now the sequence is going 1, 2, 3, 4, 5. Yeah. So divergent to infinity.
The second equation will never touch 0.
Yeah.
It'll never reach 0.
Okay, so it's infinity.
If that's not reducing.
Oh, no. Suppose I'm spending money in the bank. Okay? I have 1,000 euros in the bank, and now I have 500. Now I have 100. Now I have 1 euro. Now I have 1 cent. You don't say I have infinite money. Where's my money going?
But it will never touch 0.
I never let my bank account go to 0. Ever. Yeah. But that doesn't mean I have infinite money.
So there's no limit.
No.
No. That's a different story.
It's a vocabulary problem. What do you think limit means?
Reach at 1.
Yeah. In maths it doesn't mean this. In maths limit means the point you're trying to reach,
What's another word?
but not necessarily reaching it.
That's nothing.
Yeah?
That's nothing.
That's why it's
Number
not
like
divergent.
Huh?
That's why it's not divergent.
Yeah, like divergent is either increasing or decreasing. This is decreasing. Why isn't this divergent?
No. My first sequence, is it increasing or decreasing?
No.
Yeah, it's increasing, then it's decreasing.
Yeah,
Then it's increasing
The one on
again.
the right.
The one on the right is decreasing.
Yeah, why isn't it divergent?
It's decreasing to 0. It's trying to reach 0.
I
The word convergent means approaching a point.
think
You know?
just replace 0 with 1, I think they will understand it. Because
But it shouldn't matter. 0 and 1, what's the big difference? Difference of 1.
Thing is, they're changing-
No, hang on. Let me clear this up. It's just vocabulary, okay? So,
But I mean, convergence is just like go until you reach 1.
no, but that's what I'm saying. The word convergent and limit in maths doesn't mean this. It doesn't mean to reach the point. It means to approach the point.
It's close but never get there.
Yeah. You, like if I said, a sequence converges to 0 or converges to 1 or converges to 2, I'm not necessarily saying it will reach 0 or it will reach 1 or it will reach 2. Mathematically what it means is I will get very close to 0, as close as I like to 0. Might not actually reach 0, but I can be arbitrarily close to it.
Infinity.
Where's the infinity coming from? Like where do you see the infinity?
Just go 0.0.000000000.
But that's not infinity.
Yeah, that's
Eventually.
You're mixing the word infinity with like recurring or repeating, you know?
Never touch 0.
No, I understand that. So the process is infinitely long. It never touches 0. It'll spend eternity trying to reach 0. But its value that it's trying to reach is finite, 0.
How can I know if an equation is trying to reach something? If it's not, it's just...
That's a better question. How can we know if it's trying to reach something or not? Now, the way that we can know for certain in maths is not on this course. It's too advanced. What they do expect you to be able to do is to look at 6 terms and judge for yourself if you think it's approaching a number or not. So, like, I'll give you an example, okay? Like, if I said the sequence 2.5, okay, If I said 0.5, 0.75, 0.875 or whatever, if you were to make a judgment, do you think this is convergent to some limit or is it divergent? Yeah. In fact, if you had a guess, what do you think it's convergent to?
1.
To 1. Yeah. Possibly. Okay. Now, if I wrote this sequence down, 1, 5,000, 10 to the 20, do we think this is convergent or divergent? Divergent. Because if we had a picture in our mind of what the movement was, in the first case the movement is like this, whereas in the second case the movement is like this. We can kind of appreciate which is convergent and divergent from its movement it's making.
But do you know what the tangent is as well?
I know what a tangent is.
So you go to, there's a line, and
Yeah, no, I know.
you go to just infinity,
Yeah.
but never touch
Yeah,
You mean an asymptote?
yes, asymptote, yeah.
Okay, so it says that
Why is
the definition says that you go to infinity, but never touch.
Yeah, but you need to be careful about your English. So going to infinity and infinitely small are not the same thing. Now I'll try and explain the difference, but I have a couple of questions before I get to that. Yeah.
Can I do one more question?
On this one, another one. Oh yeah, certainly. Yeah, and the limit of convergence is the same as the limit of the what? Derivatives? Oh, we don't use that method, but it could be related to that, yes, which is what he's getting at. And which question do you want?
Page
28.5t. Okay, so just before I do that, I don't know what you need me to tell you.
I think
He's not happy with me, I know. I understand what you're saying, I do. So you're saying that it's getting to 0. How many steps will it take? It'll take infinite number of steps.
I think he's mixing up between infinity in terms of y and infinity in terms of x.
Now, mention that divergent, you say that you go just to infinity.
Say again? Wait, be quiet. Go on.
Divergent, you go to infinity. Like infinite numbers.
No, because this is maybe the problem. So if I say un is divergent,
So
that
there's
means
there's no limit.
no limit. And here, limit means there's no number you can imagine so that un is smaller than it.
Oh, but like the other one you can imagine that it will reach to 0.
Yeah. Like for example, if I said, take this sequence, 2, 4, 8, 16. This has no limit, because there's no number I could pick that you can say it won't exceed it, you know. Now, take this sequence, 1, 1.5, 1.75. This has a limit. In fact, it has a limit of 2, because it's always less than 2. It's trying to approach 2, you know. So the idea is, we say a sequence has a limit if we imagine that there's some ceiling, or perhaps the other way around, that there's some floor that bounds it. Whereas divergent means it is unbounded. Okay, I'll tell you what you need to do. You need to get some candles lit. You need to meditate on this. You need to think deeply about it. You need to imagine that you are the sequence. You've become one with the sequence, and you're divergent together. And also watch this video again. Huh?
You never get it.
Yeah, no, watch this video again later. Watch it again later. Sleep on it and watch it tomorrow. You might have better luck then. Okay, so page 28. I want to get this one done now because someone asked for it. 28, 5t. Yeah. So do you have it partly done? You have none of it done?
Because I don't know how to do it.
Okay. I'll give you what to do. 90, 3x squared, plus 30x minus 27 less than 198. Yeah? You should split this up into two problems. Now, dude with the Mo, with the graphing calculator, give me, what's that, 30x, wasn't it?
90.
Oh, you have the two values?
No, 90, not 30.
No, it's x minus 3x plus 13.
90, 3x squared, 30x minus 27, 198.
It's greater than
30, 3x squared, 30x minus... What's wrong?
No, it's right.
This is right. And then this is 3x squared, 30x minus 27 less than 198, right?
Yeah.
Am I doing 5t?
Yeah.
90 and 30.
30 is 90.
Oh, sorry. No, I got it. Sit back down. Thank you. Got it. Right. So you have 0, 3x squared, 30x, minus 27 minus 90? 117?
Yeah, 117.
And then, what's that? 3x squared plus 30x.
Minus 225.
Starting to become a habit now, Mark. 3x squared plus 30x, and then minus 27 minus 198.
Minus 227. Minus 225.
225. Less than 0. Right. What are the two answers here?
X minus 3, x plus 13. Obviously, with the
Minus 3.
and plus 13.
You're giving me the roots, not the factors. Right. And this one here?
Minus 5 and plus 15.
Minus 5 and plus 15.
How do you get 13?
Oh, a quadratic formula. Yeah. Right.
You can factor them.
Yeah, you can factor them too. So do I want to be above or below here? Below. So here to here. Above or below? Oh, sorry, this is wrong. Sorry, this is above. And this one's below.
Yeah.
Yeah, okay. Now, here, this is telling me x needs to be smaller than minus 3. But I can forget about that, because I tell you in the question that x should be a natural number. So the only possible answers here is, well, not even 13 because it's open. So 14, 15, etc. And the only possible answers here are 1, 2, etc. up until, well, not even 15 because it's open. However, there's a big and between these. We need both to be true at the same time. So what are the values which will solve both conditions? Simply 14. So 14 is the only possible number, so that if I put it into this quadratic, it'll be bigger than 90 and less than 198. Only 14. Nothing else will have me between 90 and 198 in the quadratic.
Yeah, but the answer is 4.
What?
Yes.
Are you sure?
Yep. And that's what I got.
So, and you got 14?
No, I got 4.
Oh,
Because x is greater than 3. And x is less than 5.
less than 5.
Yes.
Now, it's minus 5.
gave him minus 3.
I gave you the quadratics in the beginning, and you.
Are those solutions correct? Minus 3, 13, minus
No,
5?
it's 3 and 5.
Ah,
3 and 5.
what's 3 and 5?
Yeah.
No.
Because I don't
Oh,
graph it. I don't graph it.
Give me the two roots to the first one, please.
Okay, x is greater than 3.
No, just give me two numbers. I just want to hear two numbers.
3 and minus 13. Yeah.
3 and minus 13. Okay. And for the other one, give me two numbers, please, Mo.
5 and minus 15.
5 and minus 15. All right. So here, did you say minus 3 or 3? Okay, it's a terrible graph. So the only solutions here are 4, 5, etc. And here the only solutions are 1, 2, 3, 4, etc. And you have a big and between them. So only 4 will work. Okay.
I was giving you the quadratic.
No, it's okay, I forgive you.
answer.
Right, okay. Did you write that one down? No, I need to close this because we have another class in a couple of minutes. It'll be on YouTube in like 10 minutes.
Is it open or closed?
It is open. Okay, I have to close this now. Yeah. Right, I'm uploading it right this second. I'll just save it and upload it.